video we are going to be looking at electrons, neutrons and protons. Following Bohr's model of the atom, protons and neutrons are found in the nucleus, electrons are found in the shells, protons have a positive charge, neutrons have a neutral charge and electrons have a negative charge. Next we are going to be looking at the electronic structure of an atom and an ion. The two atoms we have chosen is sodium and potassium, and the ion we have chosen is aluminium with a -3 charge. So our first atom is sodium. It has a mass number of 23 and an atomic number of 11. Now we're going to look at the number of protons, neutrons and electrons. The number of protons is the same as the atomic number, which is 11. The way we figure out neutrons is the mass number, which is 23, minus 11. So the number of neutrons is 12. To figure out electrons, because it is not an ion, it is the same as the atomic number, so this one will be 11. The second atom we are going to be looking at is potassium. The symbol is K, the mass number is 39 and the atomic number is 19. Right, to work out the number of protons, it's the same as the atomic number, so it is 19. To work out the number of neutrons, it would be 39, the mass number, minus 19, so the number of neutrons is 20. To work out the electrons, because it is not an ion, it is the same as the atomic number, which is again 19. And now we're going to be looking at the ion. The ion we've chosen is aluminium with a -3 charge. The way to work out the protons and neutrons is the same. The protons is the atomic number, which is 13. Neutrons would be 27 minus 13, so it equals 14. But because it is an ion, the electrons is worked out differently. So you have a charge, so you have to minus that off the atomic number. So it'd be 13 minus 3, which equals 16, because a minus and a minus makes a plus. Next we are looking at electronic configuration. So in this way we're using Hund's law and the Aufbau principle. This helps work out electronic configuration for the 3 elements we have chosen. We've picked 3 elements from the S, D and P block. These are calcium, copper and selenium. We will also find out how they are located on the periodic table using this law. The Aufbau principle is electrons will fit subshells in order and each subshell needs to be filled before going on to the next shell. Subshells are ordered in proximity to the nucleus. The Hund's law is in subshells with more than one orbital, electrons will occupy empty orbitals before they pair up. The first element we are going to be looking at is calcium. The mass number for calcium is 40. The atomic number is 20. This is the number we're going to focus on. So using the Aufbau principle and Hund's law, we're going to use these squares to fill up the number of electrons. So because this only has one orbital, 2 will go in there, the same for this one. But because this has 3, they will occupy 3 all empty ones before pairing up. This one, they'll just go in the same one, they'll go the same again for this one, and then this one will be full, so that equals 20. So the long configuration would be 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. If we look at the periodic table and we find calcium, the next noble gas is argon. So this is how we'd write the short configuration. So we'd put the noble gas in brackets, and then this is the noble gas. This is the configuration for argon, so we just add the 4s2 on. The second element we will look at is copper. The symbol is Cu, the mass number is 60 and the atomic number is 29. This is the one we're focusing on again. So using Aufbau principle and Hund's law again. So this one will be filled up, so this one, but the electrons will split up before pairing up. And the same for this one. You just carry on going till you get to the number 29. Yeah, so the long configuration for this one would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d9. And the same again. The next noble gas to copper is, you work backwards, again is argon. So you'd put argon in brackets. And we learnt from the last one, argon only goes up to 3p6. So we'd have to add 4s2 and 3d9. The last element we have chosen is selenium. So it's Se. The mass number is 79. The atomic number is 34. This is the number we're focusing on. So using Aufbau and Hund's law, we will fill up the subshells until we get to 34. So these go in separate ones before pairing up. Same with this one. So the long configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 and 4p4. So using the periodic table, we find selenium, which is here. So we've got to go back again to argon. So it would be AR in brackets, and then it only goes up to 3p6. It only goes up to 3p6, so we have to add 4s2, 3d10 and 4p4. Using these methods, you can work out any element on the periodic table. Thank you for watching.